Hello, everybody. My name is Braack. I'm a software engineer at Grafana Labs, working on the OpenTelemetry team. And in those 5 minutes, I'm going to show a new piece of technology we've built over the last year that allows to ingest delta metrics into Prometheus and other backends. It's part of the OpenTelemetry collector, and it is released in the official OTel code binaries as of about 2 weeks ago. For those unfamiliar, temporality is essentially a dimension on the data you're sending, how it's aggregated. And Prometheus only supports what's called cumulative temporality, which is what you would see in the top line here. So think you do have a counter metric. It's like an aggregation over typically the process starts. So it's like a 12, a 14, a 17. In Prometheus, it usually doesn't go down. In other systems, it can, but that does not matter too much here. An alternative that has certain benefits in some areas is delta, which instead of sending a summarized value over the time, you only do send an individual change. So a +12, a +2, a -7. And even though you can send samples like that into Prometheus, you can't really do a lot with them then, because PromQL and the whole Prometheus ecosystem is not built for that type of data. So a conversion is most likely required. To showcase that, I wrote a very short OpenTelemetry SDK program that sends random values into Prometheus, or using OTLP to a collector and then into Prometheus, to be exact. I'm storing the same value as a sum and a gauge, so we can compare in Prometheus later on how the conversion actually happened and what it did. This is my Docker Compose setup for the OpenTelemetry collector and Prometheus. All of this code is public on GitHub on /talks, so you can take a look at that later on. The OpenTelemetry collector uses a pretty minimal configuration in this example, so I'm setting up the OTLP receiver to actually get the metrics in from the application. The delta to cumulative processor, the thing we're talking about here, doesn't even take any required configuration. And we do export that to a Prometheus running locally, which has the remote write receiver enabled. I ran that in advance already, and when looking at the gauge, so like the unconverted data, we can see that it looks like a random, it's the random distribution you would kind of expect to see here, and all of those are positive values, some higher, some lower. But given we are technically counting something here, this is not exactly useful. If we do take a look at the converted version, however, the random sum total here, you do see what you would expect to get when entering a bear counter in Prometheus. That's the whole talk.